In this video, I want to work on problem 1 from Precept 5. So what we need to do here is demonstrate overfitting. What does overfitting mean? It means that you get better performance on the training set at the expense of worse performance on the validation set. So let's set things up simply by first just creating a training and validation set. So we'll do it like this. This is just code from lecture, and I'm loading Titanic here as well. So I have train IDX, that's the indices in the train set, and I have validate IDX, that's the indices in the validation set, and we have 500 points in the validation set, and we have 100 points here in the training set. So in order to actually get the training set, for example, I would go Titanic, that's the data set, and then I would go train IDX, and then I want, let's say, all the columns. So what they'll get is they'll just get those specific rows, so the rows in train IDX from Titanic, right? So those are the numbers of rows. There is 100 of them. So, okay, all right. Let's first just try to train or fit one model and then see how we do it with multiple models. So I'll go GLM, and what I'm doing is I'm predicting survival. So survived age plus sex plus P class, and P class will treat as continuous. We'll go family is binomial, and we'll say that data is Titanic.train. So before I use it, I need to actually create it. So I'll say Titanic.train is Titanic, just like what we did before. So train.idx and all the columns. And that's going to be our model. The model is fit using the training set. So let's also create the validation set while we are at it. So I'll say Titanic valid. And here I'll swap train for valid as well. So what can we do with this model? We can try it on the training set, and we can try it on the validation set, right? So what do I mean by try? We can try to predict using this fit. So I can say predict, and then I'll say fit, and I'll say new data is equal to Titanic.train, and I'll say type equals response. So those are the predictions for all the rows in the training set. If I want them to be either 0 or 1, what I'll do is I'll do greater than 0.5. Why 0.5? Well, because here type is equal to response, so those are probabilities in the range of 0 to 1. If it's greater than 0.5, we'd predict 1. So those would be the predictions in the sense of 1 or 0, or same thing, is to say true or false. So in order to know the performance here, what we would do is we would say, okay, like, is that equal to Titanic train survived, right? And if it is, for every row, if it's true, then we say that's a correct prediction. If this is not equal to this part, then the prediction is incorrect. So here we'll get a bunch of trues and falses. So every true corresponds to a correct prediction. Every false now corresponds to an incorrect prediction, because a false just means that the entry here did not match an entry here. So now if we do mean, here, for example, we got 80% correct. We can do the same thing on the validation set. So here I'll say Titanic.valid, and here I'll say Titanic.valid as well. So that was not defined yet, so we'll do that. And here we see that the performance is very, very slightly smaller at 77%. Now, the important thing to note here is I just obtained this fit once, right? And I did it using the training set. So the training set, just by definition, that's what you use in order to fit the model, in order to obtain the coefficients. You do not do that on the validation or the training set ever. Okay, well, so on the validation set, you sometimes try different things, but you never actually fit the coefficients on the validation set either. So the point is not that this is called Titanic.train, the point is that this is the set on using which we fit the model. So okay, what we want to do now is we want to actually do this same thing multiple times in order to see how things change when the training set is small. So first I'll just do it by hand. So I'll just change train.idx to, let's say, train.idx 1 through 10. So just so that this is 10 indices rather than 100, and I'll see what happens. So I redefine Titanic.train. So what you see is here the performance actually stayed the same. That seems implausible. Oh, so here the problem was that I did not actually redefine it. So now the performance is 90%, and the performance here dropped substantially to 56%. So you see that if I make the training set smaller, and here I did make it smaller because the size of this set is just 10 rows, right? Then the performance on the training set will increase on the new training set, and the performance on the validation set, and that is the old validation set, stays the same. So okay, now that is basically what we want to do, except we want to do it multiple times. So what we'll do is we'll set up a function that does those things, right? And then we'll run it on different sizes of input. So okay, so I'll just wrap this in a function. So how to do that? I'll say, let's call this function getTrainValidPerformance. It's going to be a function. So what do I need here? So I need the training set. And I need the validation set. So I'll assume that this is going to be done outside the function. So I'll enclose it in braces. I'll do this. So now I'll say this is the performance on the training set, so let's call it ptrain, and this is the performance on the validation set, so let's call it pvalid, like this. And now we can just say, well, I want to return both of those things, so I'll return both ptrain and pvalid. Okay, so let's define this function and then let's try it out. So here I want to say, okay, so let's say that this is Titanic train and this is Titanic valid. So if I define those, and then I'll say get train valid performance like this, and I'll give it my new Titanic train that I just made, and I'll give it Titanic.valid. And what I get is what I got before, so 90% on the training set and 56% on the validation set. So okay, now what I really want to do is I want to make a function that takes the size of the training set as input. So I'll make that function, and this basically involves wrapping this in a function as well. So this function I'll call getTrainValidPerformanceSize, like this, and that'll take train.size, and it'll take Titanic, so the original data set, and train.idx and valid.idx. So note that actually, like, those things, Titanic and train.idx, those are defined outside the function, so in principle I could just use them, but it's bad practice. So it's good practice to give the function everything that it needs in order to compute the output. So that's what we're doing here, and let's open the brace, close the brace here. So now I'm defining Titanic train, so here we're going from 1 to train.size, and then all the rows. The validation set stays the same, and now the performance is going to be this, so we can just say performance is this, and at this point we can just return it. So we could even say just return, well, let's say return perfs, but you could just as well have said return all of this. That would be fine too. So let's try it now. So I define this function, and I'll say get training size, and here this is train. So I'll say train size, let's say 10, and then I give it Titanic, that's just the entire data set. I give it train IDX, that's the indices that I just generated, the ones, and I'll give it valid.idx. Those are the validation indices. So if I run it, apparently train size was not found. So here we said 10, and we said Titanic, so that is fine. So here train size, this is apparently not the same. Try it again. Okay, so there was a typo there, so now it's all good, and we get the same thing. Now, of course, we could change this 15, so now let's try a size of 15 for the training set, and what you get is actually much better performance on the validation set and a lower performance on the training set. You could try something like 5, and here you get the warning, but you still get the results, which is 100% on the training set and just 51% on the validation set. So now that we have set everything up like that, we are ready to use sapply. So let me define sizes as all the sizes that I want to try. So let's say that I want to try 5, and I want to try 10 and 15 and 20 and 25. And let's now go in increments of 10. So 45, and let's say 65, and let's say 75, and let's say 95. So let's say that those are our sizes. So now we'll go sapply. So each one of those sizes, the function is going to be get train valid performance train size. And now we need to supply all of those things, which we already defined before. And those would be the performances that we get. As you can see, what we get is so this is actually a matrix, but you can use it just like you would use a data frame. So if I save this result to A, for example, this is A, and I can get the first row by just saying I want the first row and all the columns, and I could get the second row like this. So we'll graph all of this in the next video.